Hi, I am going to present to you the CoastObs project. CoastObs is a H2020 downstream applications project and the acronym stands for Commercial Service Platform for user-relevant coastal water monitoring services based on Earth observations. I'm Steef Peters from Water Insight. I give this presentation on behalf of the CoastObs Consortium, which consists of many renowned research institutes like University of Stirling, CNR, University of Nantes, University of Applied Sciences, de Hogeschool Zeeland, University of Vigo, Bioliteraal en Geonardo. The project started 3 years ago and is coming to an end early this year. The intention was to produce user-relevant, marketable, innovative Earth observation-based information products and services. It has been clear from other projects in the past in commercial services that the end-user uptake of Earth observation-based services can only start when user requirements are matched with product and system development. To lower the cost of production and to reach the point where clients are willing to buy the product, we have to lower the cost of production by setting up automated information production systems. As you see, we have quite an elaborate vision of how to engage with the user. One of the central core philosophy of CoastObs is to have demonstration cases. We have a lot of communication with users and have them engaged in what we do. In the end, we set up a service portfolio combined with a marketing and business plan. All our activities are strongly matched with product validation because we see that users are really interested in buying and obtaining validated products. The result of CoastObs can best be summarized by the table of contents of the product and service portfolio. We produce, based on case studies and the algorithm studies, chlorophyll A maps, total suspended matter maps, turbidity maps, sea surface temperature and shoreline mapping. Building on these basic products, we provide innovative products and higher level products. The innovative products are the intertidal seagrass maps, phytoplankton primary production and harmful algae blooms indicator. So for the higher level products we do statistics, indicators for Water Framework Directive, reporting, harmful algae blooms indicator again, shellfish culture potential, which is very nice and an important application, phenology of phytoplankton blooms and the morphology of sediment blooms. As I said, the project is centered around 4 case studies, namely the Dutch coast, the case study in South Brittany, in Galicia and the Adriatic coast. In South Brittany we focused for a large part on the mapping of intertidal seagrass, and we produce now maps of seagrass percentage coverage of meadows of seagrass dominated by Zosteria maltae. The maps are produced by using Sentinel-2 images, and we really need a pixel size of 10 meters for that. In the Dutch coast, the case study focused on modeling the potential for mussel growth. In this case we use Earth observation to drive the predictive model. As you see, the maps in colors show the predicted mussel size actually. So this is a very powerful tool and very of great interest for the users. We also try this now in Spain, in Galicia. In the Adriatic coast, Venice Lagoon, the colleagues of CNR worked on looking at the turbidity in the Venice Lagoon, and there was a very high profile study around the first lockdown during COVID-19, where you could see the high impact of not having many boats and tourists in the lagoon anymore, and the sudden clearing up of the waters. In Galicia, the interest was mainly focused around the impact of harmful algal blooms on the growth and harvesting of mussels. There, a model was set up to predict if there would be a bloom or not a bloom of Pseudonychia, and it was validated against field observations if there was a false positive or false negative. The project paid a lot of attention to validating the products. So we measured reflectance, seagrass, density, surface percentage cover above and underwater, and many optical properties of water and the apparent optical properties and concentrations of water constituents were measured and used to make locally tuned algorithms. The products are shown to the users in web portal. The web portal is coastobs.lizard.net. In there people can see examples of what CoastObs has been producing. First they have to request a password and user access to us, Water Insight, and then we can help them to navigate the portal and look at the sample datasets. One of the latest achievements of CoastObs is the e-training platform. We think this is very important to help users understand what ocean color remote sensing can do for them, what kind of information products they can find based on Sentinel-2, Sentinel-3 and the models that we have produced, so that the users are further engaged in what we do. The take-home messages from the project are, I think, very clear. The 10-meter resolution Sentinel-2 MSI images provide very useful user-relevant information for local ecosystem studies. The 300-meter resolution Sentinel-3 ALSI data provide also very useful information for driving hub and mussel growth models, but they are very near the coast. So maybe there's scope for a 100-meter merged product. Unfortunately, no one-size-fits-all solution is there for atmosphere correction, so this has to be determined per location, per area, per application maybe even. We think that our locally tuned algorithms are required, also to harmonize the results with the user data time series. Users are very enthusiastic and interested, but their engagement has been extremely difficult for the past year, for obvious reasons. The case studies were very successful and the commercial potential is clear to us, but it will require some follow-up work. So, thank you.